When you see this one, what do you hope it is? Geometric series. Okay, so let's just look at the ratio between a couple of them here. If you go from there to there, what do you multiply by? 5 over 4. Or negative 5 over 4. What about from here to here? Negative 5 over 4, right? So this is going to be the sum as n goes from 1 to infinity of negative 2 times what? Negative 5 over 4 to the n minus 1, right there. So the absolute value of r in this case is greater than 1, so what does that mean? Divergent. It's divergent. Cool? Yeah? Okay. Anybody have any ideas about how to prove that this diverges? How do we show it diverges? What could we do? Well, hold on. That's one way to say it, but let's try to add in some more of a math vocabulary in there. I totally agree with what you're saying. I like what you're saying, but we're going to look at the limit as n goes to infinity of this thing, right? If we divide top and bottom by n squared, we end up with the limit as n goes to infinity of 1 over 5 plus what? 4 over n squared. And what is that going to go to? 1 over 5. The limit as n goes to infinity of an does not equal 0, so divergent. So you have all these ways. Usually, in my experience with math, I love counterexamples. You basically come up with one, but all you're doing here to come up with your one quote-unquote counterexample is that you're trying to see if it goes, oh, it doesn't go to 0, so that's helpful. If it went to 0, does that help us at all? Not really. It doesn't help us come up with a final answer. If it went to 0, that's not sufficient. That's not enough. But if it doesn't go to 0, score, we're done. Okay, so what do you think? How do you go about doing this one? What do you think? What should I do first on 45, guys? I know all of you have a good idea about what to do on this one. Or you could just do cosine x over 2 all to the what? All to the n power. So just like what we did on the quiz. You could do the first two sums, yes, or you could just rearrange it like this. And therefore, in this case, your r value is what in this case? It's cosine x over 2. And you want it to be convergent, so you want cosine x over 2 absolute value to be less than what? 1. So when is that true? Well, hold on. Yes, well, the cosine of anything is already less than, you're making it smaller, right? So since you know cosine of x is already less than this, so it is going to converge for what? For all x. That's the upside down a. For all x contained in the... I don't need to go any further, but it should converge for everything, correct? So then how do you figure out what it converges to? What does it equal? What's the a value? What's the a value? 1. Oh, you have to be very careful. You're right. So there it explicitly says. Interesting, interesting. The formula we have, you're absolutely right. What's the one we have? N equals 1 to infinity of AR to the what? N minus 1. This is to the n power. This is to the n. Ooh, very good. So how are we going to rewrite this? I totally see what you're saying. That's a very good catch, Andrew. If we rewrite this, it's going to be the summation of n equals 1 to infinity. If it starts at 1, what do we have to put in front of it? Cosine. I understand it starts at 0, but if we move it to 1, if we started at 1 instead, what's going to go in? Okay, I'll say it. Expand this out. Look, if we expand this out, you're adding to. What's the first term going to be? You're plugging in 0, right? Anything to the 0 power is going to be 1. It's going to be 1. So you can write it like this. No, I think it's very good of you to check this. N equals 1 to infinity. What is the first one? First one is 1. So it's going to be 1 plus cosine x over 2. Yes, exactly. Cosine x over 2 all to the what power? Does that work? Is it still to the n? Is it still to the n? So what do we do with this? factor out a cosine x over 2? What do you mean? From
So
follow what you're saying. So you want to do it like this. You want to do the summation, and still 0 to infinity of cosine x over 2 times cosine x over 2 to the what power? N minus 1, like that.
You would still have to.
Now, it doesn't need to. Does it change anything to start it at 1 or 0? In this case, does it affect our answer? It will, because here's the thing. Look, if we start this thing at 0, what is the first term? If you plug in 0 for this thing, if you plug in 0, what do you get? You sure?
Yeah.
Oh yeah, because it flips it over. That's really cool. You're absolutely right. So what do you end up with? Cosine x, if n equals 0, cosine x over 2 times cosine x over 2 to the is equal to 1. So what we can say, I understand, yes. So now what can we say? We can say that 1 plus the summation of n equals 1 to infinity of cosine x over 2 times cosine x over 2 to the n minus 1. So now is this in the proper form? I think it's good. I think it's great. After here. Okay, so now in terms of this thing right here, what is our r value? Cosine x over 2. And what's our a value? Cosine x over 2. So in this case, we're going to end up with 1 plus a, which is cosine x over 2, all over 1 minus cosine x over 2. Exactly. So how do we clean this up? So you just want to do your algebra properly. Cool. Okay. So we end up with, a lot of things cancel. 1 plus cosine x over 2 over 2 minus cosine x all over. Gives me 1 plus cosine x over 2 times 2 over 2 minus cosine x. What cancels? So you're left with 1 plus cosine x over 2 minus. That looks pretty good. What do we think? See, so you could say this is equal to, you're absolutely right. So it's going to be 2 minus cosine x plus cosine x all over 2 minus cosine x. So what do you end up with? So it was not a typo, it's correct. Good. Good job. Any ideas? You could. You could start writing terms. You absolutely could. And what do you notice if you start writing terms?
You get the natural log of n plus 1 over.
How do you, oh, look at that. So how about we do what you just said out loud first to infinity of ln of, let's just change what it says inside. It's n plus 1 over n. Do you remember your log rules, everybody? Yeah, there was an emphatic love. N of n plus 1 minus ln of n, right? So when you start writing this out, what happens? You end up with ln 2 minus ln 1. That's your first one, right? Plus ln 3 minus ln 2 plus ln 4 minus ln 3. So what ends up happening here? That's gone, right?
Yeah.
And then what happens?
Just all the middle terms after that.
All of them are gone, right? So what do you let? And what's ln of 0? What's ln? Sorry, excuse me. What is negative ln of 1? It is 0, right? So what's the last term that's going to be here?
Negative ln
of what?
n plus 1.
No, because remember, it jumps ahead. It cancels the one here. The one that's left is right here. It's n plus 1. So you're going to end up with, look, you're going to have ln of n plus 1 here, minus ln n, but then the one before it is going to, well, actually, it's going to cancel. Right, so you end up with the limit as n goes to infinity of ln of n plus 1. So what's that? So what is this? And I keep on forgetting to plug this in.